This is Plant-Based Briefing, Antimicrobial Resistance, Increasing the Impact of Pandemics, Part 2, from ProVeg International at proveg.com. And I'm your host, Marian Erickson, and this is the Plant-Based Podcast, where I research and curate a variety of articles on plant-based, compassionate, and eco-friendly topics, get permission, and read them to you here in about 10 minutes or less every weekday. And today's article is longer than that, so it's a two-parter. I had read part 1 yesterday, so go back and check that out first so that this part today will make sense. And now let's get to today's plant-based briefing. Antimicrobial Resistance, Increasing the Impact of Pandemics, Part 2, from ProVeg International at proveg.com. Wasting powerful drugs on animal agriculture, including antibiotics of last resort. Two of the most commonly used antibiotics in animal agriculture are tetracyclines and fluoroquinolones, both of which are also used to treat various severe illnesses in humans, including cholera and malaria. Resistance to tetracyclines has already been detected in industrial poultry farming, and the use of fluoroquinolones also poses a public health concern as they're suspected of encouraging bacterial resistance, which can be transmitted into the food chain. The misuse of antibiotics in animal agriculture also extends to drugs of last resort. That is, antibiotics which are used as a last line of defense for humans whose infections are failing to respond to standard drugs. Life-saving medicines for humans such as colistin are wasted, mostly on healthy animals, in order to boost their growth and weight, or to prevent them from contracting infectious diseases resulting from inadequate husbandry conditions. Colistin is used in the treatment of E. coli infections, but also used to treat pneumonia. Resistance to colistin has been detected around the world, with nearly 100% of farmed animals in some regions, as well as a rising number of people, carrying the resistant gene. Since colistin is a valuable drug that is used to treat multiresistant bacteria, this development poses a serious and growing global threat. Factory farms and aquaculture, breeding grounds for dangerous superbugs. There is a strong link between the intensive use of antibiotics in animal farming and the rapid emergence of new resistant bacteria, leading to a record level of superbugs in various domesticated animal species. Superbugs are microorganisms that have developed multi-drug resistance. This holds particularly true for the clear increase in resistant bacterial strains occurring in chickens and pigs. Globally, the production of animal-based products is estimated to increase by 15% by 2028. This increase in meat, milk, and egg production also implies a rise in antibiotics use in animal farming, which is projected to rise by 67% by 2030, with some countries expected to see an up to 80% increase. Global AMR maps, available at resistancebank.org and ourworldindata.org, show that the countries with the highest resistance rates are also the countries that have the highest use of antimicrobials commonly used by humans, also used in animal farming. The indiscriminate use of antibiotics makes the aquaculture sector another hazardous breeding ground for AMR, and one that deserves special attention since aquaculture is one of the fastest growing food production sectors worldwide. Global fish production rose to about 171 million tons in 2016, with aquaculture constituting 47% of the total. As aquaculture intensifies in order to meet global demand, so too do the diseases and pathogens affecting aquatic animals. The intensification of aquaculture enables an ideal setting for rapid changes in pathogen populations, genetic exchange, and recombination to take place. All of these factors have long-lasting evolutionary effects on pathogen virulence and outbreaks. Furthermore, many countries practice an integrated agriculture-aquaculture farming system in which aquaculture is sustained via livestock and human waste, maximizing the exposure of animals, humans, and the environment to AMR. Animal agricultural waste and the spread of AMR. Factory farms produce large quantities of waste, which in most cases is disposed of in nearby areas. This increases the risk of the transfer of AMR genes to farmed animals, humans, wildlife, and watersheds. Antibiotics not only pose a direct threat to overall human health, but also have an impact on the environment. Most of the antibiotics are excreted and disseminated into the environment via runoff water or manure used as fertilizer, after which they get into rivers, lakes, and groundwater used for human consumption, as well as into our soils. In this way, they potentially alter the microbial community and cause the emergence of new resistant strains. Animal agriculture workers and the spread of AMR. Factory farms enable frequent and close contact between animals and people who work on or live close to the farms. Methicillin-resistant Staphylococcus aureus, MRSA, is a clinically significant superbug that causes infections of the respiratory system worldwide. In Germany alone, there are about 132,000 cases of MRSA each year. MRSA is widespread in various different species of farmed animals and is easily transmitted to humans who are in direct contact with them. In German regions with high numbers of farmed animals, 86% of hospital-admitted MRSA cases are farmers, and more than 4% are farmers' relatives. AMR and poverty, a vicious circle. Drug-resistant infections have become harder to treat globally, but the burden of bacterial infections is highest in low-income countries and vulnerable communities. In low-income countries, many people lack access to basic and affordable healthcare facilities and often attempt to self-medicate. In combination with poor infection control, a lack of education, and inadequate sanitary conditions, this encourages the spread of AMR. Poverty-related infectious diseases such as tuberculosis or TB are at the center of the AMR challenge. TB kills 1.5 million people every year, more than any other infectious disease, 214,000 of which die from multi-drug-resistant TB. In addition to its disastrous health impacts, AMR also has profound secondary consequences, such as exacerbating global poverty and inequality. Illness always tends to have a disproportionate financial impact on the poor and disadvantaged. AMR poses a huge challenge for the economies of low-income countries because it renders the treatment of diseases harder and more expensive. This makes it a fundamental developmental problem. The World Bank estimates that by 2050, 28 million people might face extreme poverty every year due to AMR, of whom the majority, 26.2 million, would be in low-income countries, resulting in global economic costs of $1 trillion per year. Poverty and AMR form a vicious circle, with AMR exacerbating poverty and poverty facilitating the spread and development of AMR. AMR, the superbugs we grow in our farms. Instead of using antibiotics to keep humans healthy, our current food system wastes these valuable drugs in order to maintain the lives of animals who would otherwise not be viable under the circumstances they are kept in, all in order to produce large amounts of cheap animal-based products. As a consequence of the ever-increasing global demand for animal-based products, the unabated growth of antimicrobial resistance is particularly alarming, since the massive misuse of antimicrobial drugs increases the risk of the impacts of pandemics becoming even more severe. The current model of animal agriculture not only enables and encourages viral evolution and transmission, but also increases antimicrobial resistance. This alarming combination poses a threat to human health everywhere, regardless of whether people eat the animals raised under those conditions or not. In terms of the increase in antibiotic resistance, there is a further connection with our animal-based food system and what we eat. Many microorganisms that have developed antimicrobial resistance are also involved in foodborne diseases. These include Salmonella, Clostridium, Campylobacter, Staphylococcus, E. coli, and Listeria. Crucially, they all have meat or dairy as their main sources. You just listened to Antimicrobial Resistance, Increasing the Impact of Pandemics, Part 2, by ProVeg International at ProVeg.com. And I'm Marian Erickson, your host. And this is a topic that's been in the news for years. But as far as, mainstream news and mainstream media goes, mostly what we hear about is doctors overprescribing antibiotics and the overuse of antibiotic soaps and hand sanitizers, disinfectant wipes, that kind of thing. But that is nothing compared to the overuse of antibiotics in animal agriculture. If you Google antibiotic resistance or antimicrobial resistance, you'll see pages and pages of government sites and medical sites, but almost nothing from mainstream media. However, there's a great new documentary that's come out about this topic called The End of Medicine as We Know It. And I'll put a link to it in the show notes, but you can find it at vegmovies.com. So please check that film out and please share this episode with anyone who might benefit, and thanks for listening.